let's talk about converting points from polar coordinates to rectangular coordinates. So let's start with the point 8 pi over 6. So here's our point in polar coordinates. And let's draw a picture of it. So we know this point lies on the terminal side that is pi over 6. So let's draw that angle. Here's pi over 6. And r is 8. So from the pole, remember in polar coordinates we call that the origin the pole, we would go out 8 units. So this point right here, if this length is 8, would be the point 8 pi over 6. But our task is to find what that would be in rectangular coordinates. In other words, if we were to find this x value right here, and this y value, and we wrote it as an ordered pair, we would have the representation that we need. But we have a triangle, and we've done this so many times in trig. If we know this angle is pi over 6, and we know this radius is 8, notice to find the x value, we could use the cosine of pi over 6. So let's write that. Cosine of pi over 6 equals x over 8. Similarly, to find the y value, we know we have the sine of pi over 6 is y over 8. And if we multiply both sides by 8 in both equations, we have our x coordinate as 8 cosine pi over 6. And our y coordinate is 8 sine pi over 6. So I do want to point out that this value is r and this value is theta. So when we substitute in our value for pi over 6, or for the cosine of pi over 6, we know the cosine of pi over 6 is square root of 3 over 2. So our x value is 4 square root of 3. And when we substitute in the value for the sine of pi over 6, which we know is a half, we have a y value of 4. So this point that is written as 8 pi over 6 in polar coordinates, in rectangular coordinates would look like this. 4 square root of 3, 4. But what we just did with this specific point could be done in general. Let me show you. Let's suppose we have a point that is r theta. And let's draw it on the plane. And I'll put it over here in the second quadrant. We'll say theta looks like this. And of course, r is the distance from the pole out to the point. And when we draw our reference triangle, as you know, we could label this as x and this as y. And with respect to this picture, we know the cosine of theta is equal to x over r. And we know the sine of theta is y over r. And when we multiply both sides by r, we would have x equals r cosine theta, and we have y equals r sine theta. And that will be the formula that we can use to easily convert from polar to rectangular when we're dealing with those ordered pairs. And it doesn't matter if r is positive or negative, or theta is positive or negative. These two equations will always hold. So let's do another problem. We're going to use the point -6, 3 pi over 2, or 3 pi over 4. So we have negative 6, 3 pi over 4. And our job is to rewrite this point that is in polar coordinates as a point with rectangular coordinates. So let's write the formula. We know x equals r cosine theta, and y equals r sine theta. And we can just substitute those values in. So r is negative 6, theta is 3 pi over 4, and our y value is negative 6 sine 3 pi over 4. Let's substitute in the values that we know for the cosine of 3 pi over 4. We know that that's in the second quadrant, so that will be negative, because it's in the second quadrant, negative 1 over square root of 2, or negative square root of 2 over 2 if you prefer. Similarly over here, we substitute in the sine of 3 pi over 4. Again, it's the second quadrant, but the sign is positive in the second quadrant, so it is negative 1 over square root of 2, or negative square root of 2 over 2. So when we multiply, we have 6 over square root of 2, and here we have also 6 over the square root of 2. What did I do? I said positive, but I wrote negative. Let's fix that. So we have negative 6 over square root of 2. And often I don't care whether the denominators are rationalized, but with a square root of 2 in the denominator and an even number in the numerator, this isn't particularly nice. Let's rationalize the denominator. So we would have 6 square root of 2 over 2, which would simplify to be 3 square root of 2. Similarly here, we have negative 6 square root of 2 over 2, which simplifies to be negative square root of 3 over 2. And it's finished. We haven't written it as an ordered pair in parentheses, but we have the x-coordinate and the y-coordinate. Let's confirm that at least the signs seem right. I just did it without drawing a picture because we know these equations are valid always. But let's draw a picture. 3 pi over 4, let me remind you how we would graph this one. 3 pi over 4 we know is over here. But with an r value that's negative, instead of going forward, I would go backwards in the opposite direction. So in fact, the point that we're talking about is over here, with this distance from the origin to the point being 6. And what we have just found is that the x-coordinate is a positive 3 square root of 2, and the y value is a negative 3 square root of 2, and you could confirm that that is correct because we have an isosceles right triangle here in the fourth quadrant. Let's do one more problem. So the question is the same, to write the problem, or write the point with rectangular coordinates, and let's just make it look like this. So here it is in polar coordinates. We'll make it 2.3 and negative 5 pi over 12. And our goal is to rewrite this with rectangular coordinates, but again, we know those formulas, so let's just jot them down. X equals r cosine theta, and y equals r sine theta. We pop in those values, so we have 2.3 cosine negative 5 pi over 12, and we have 2.3 sine negative 5 pi over 12. Now negative 5 pi over 12 isn't one of my special angles, so let me use a calculator and find a decimal approximation for it. So we have, make sure your calculator's in radians. So I'm going to take the cosine of negative 5 pi divided by 12. and I'm going to multiply that by 2.3. So we get an x value that is approximately, and then pay attention to what your directions in your problem might ask. I'm going to go to 2 decimal places. Let's go to the nearest hundred. So this would be, is about 0.595. That means I'm going to round to 0.60. So the x coordinate for this point would be about 0.60. Now let's do the same thing here. We're going to find that value. So I'm taking the sine of -5 times pi divided by 12. And I'm going to multiply that result by 2.3. And I get about -2.22. So I have this ordered pair, 0.60 and -2.2. Yeah, the previous problem I didn't remember to write it as an ordered pair. Should finish it off and write it that way. So I hope you can go practice converting from polar coordinates to rectangular coordinates.